So first up, I wanted you to see exactly what it is we're looking at tonight. Okay. So it's going to be solving equations. This is a departure from what we've been doing, which is all simplifying. But you're actually going to get x equals, a equals, and y equals, and all that good stuff. Okay. But basically, you've done, I think, everything up to 22 before. Just how do you get rid of a square root within an equation? You square both sides. And just remember, anything to the 1/2 power is the same as the square root. And we'll practice a few of these that you've done before, remind you about a few details. But then we're also going to apply it to third roots, fifth roots, and higher roots. So instead of squaring both sides, you might have to cube both sides because it's a cube root. But other than that, it's pretty much the same. Should not have too many difficulties here. A little review from Friday. Denominator cannot have what? Fraction. Yeah, it's actually 2. You cannot have fractional exponents. And also you cannot have negative. Okay, so 2 parts. That's what we just went over on number 17. Did that. Here's a lot of review. This is all included in what we just kind of went over. I just want you guys to do number 6 real fast. Go ahead and square 5 minus root 3. Go and see what you get. You're going to need this skill for today. You're going to have to do this when you square both sides of some of these equations. You'll have to do squaring of a number minus a radical. You have to remind yourselves how to do this. It's Algebra 1 stuff. You can FOIL, you can use the box, whatever you like. Make sure you do it accurately. What does it come out to? Factor 5? Yep. Negative 5 root 3? Negative 5 root 3? What's the last part here? 3. Oh, yeah. Positive, right? Yeah, so it says the diagonal you get negative 10 root 3. And then you get another 3 on the back end. So really this comes out to 28 minus 10 root 3. So just know when you square both sides. It's also possible to get 3 terms if this was like 5 minus square root of x. You wouldn't be able to combine the first and the last if you stay separate. That happens as well. But this is about as difficult as it's going to get. Let's see how we're doing this. Alright, just watch me on these. Let's see, these aren't too bad. I'm always going to get the radical by itself. I'm going to choose the correct number to multiply by. But basically, the easy way of saying this is that if it's a square root, square both sides. If it's a cube root, cube both sides. That's all step 2 means. We're going to solve it, and then we're going to do some checks. Alright, so for instance, isolate the radical. That means get this radical by itself. You get it by itself. So we have 6. And some of these basic ones, you'll be able to probably spot the answer a mile away. So they're saying, well, square root of what actually is 6? Square root of what number is 6?
36.
36. So what number does this need to be? 38. Yeah, 38 minus 2 is 36. Square root of 36 is 6. Not too bad. How do you prove it? Count correctly. Again, it's a square root, so square both sides. Square root and squares cancel each other out. And you can prove exactly what we just did mentally. X is 38. And the nice thing about all these is that you can plug them in and check them. So 38 minus 2 is 36. Square root of 36 is 6. 6 minus 1 is 5. And we're ready to go. A side note, why does the square root sign get canceled out by squaring? Why does that work? Why does that happen? All right. So, sidebar, square root of x minus 2 is the same as x minus 2 to what power? 1/2. Square root is the same as 1/2 power. So, if we square both sides, you would multiply those exponents, right? What do they multiply to? 1. Anything to the 1 power is at anything. You can see why squaring cancel each other out. 1's to the 1/2 power, 1's to the 2 power. When you multiply it, it just equals 1. Good. So these are the more basic ones, because what makes it basic is that one side is just a number. One side is just a number, that's one of the easier ones. Here, on number 2, you have two sides as radicals. We cannot isolate the radical because we have two of them. So on this is where we have to use that warm-up question. Square both sides. Left-hand side's easy. The radicals and squares just cancel each other out. You're left with x plus 15. But the right-hand side looks a lot like the warm-up. So we have to multiply that out correctly. Go ahead and do that part, see what you get. Using the same method as before. What do you get when you square 5 plus root x? Just a second. Lily, what'd you get? 25 plus 10 of root x plus x. Unlike the warm-up, see how this was an x instead of a number like root 3? That's why we have 3 terms here. If this was a number, it would have been something like plus 3, and we can combine the first and last term, but since it's just variable, it will be. All right. And now we can isolate the radical. So we have one radical, now we can get it by itself. If you have one radical, that's easy. At the beginning of the problem, we have 2 radicals. Not as easy. So we can get that radical by itself by just get rid of the x, get rid of the 25. Subtract x, subtract x. 5, 5. Clear out everything away from the radical. X minus x, 0. Negative 10. These are zeros, right? 25 minus 25, x minus x. You're just left with any of x. The rest is just solving. Divide both sides by 10, yeah. And lastly, square both sides one more time. 1 equals x. So that's our answer so far. Go ahead and do a check. Plug that in, see if it works. Plug that into the original equation. Doesn't work. Got to do a check. Every time you have an equation, you can do a check. Doesn't take too much time, and it's worth it. So, yes or no, verify it, does it work? Doesn't work? No? 1 plus 15, 16. Square root of 16, 4. Square root of 1 is 1. 5 plus 1 is, oh yeah, does 4 equal 6? No. X does not equal 1. There's no solution. No solution. This will happen quite regularly. Anytime you square up both sides, there's a possibility of this happening where you can get an answer, but it turns out it doesn't work. This is called an extraneous solution as opposed to a regular solution. It's extraneous because it came out of the fact of squaring both sides. When you start squaring positives, you get positives. When you square negatives, you also get positives, which leads to some potentially wrong answers. Okay? It all comes from when you square both sides, or square positives, you get positives. When you square negatives, you get positives. You get some false solutions. So you'll see quite a few of your homework questions. You'll come out to a number. The correct answer will be no solution. And I know on the test there's going to be people that will do all this work, and then this mental math right here they'll skip and they'll get the wrong answer because they don't really believe in checking work. It's like one of those things like, well, I know it'll make me get more points, but I can't be bothered. I don't know why. This is one of those things you should be eager to do. If I do this, I know if I have the right answer. I know if I can move on and, or turn in my test if I'm done. Because if the check comes out correctly, you're done. So always do that. All right, let's walk through a little bit quicker the next two. Once again, first step. What we got to do first? Add one both sides. Good. That's outside the radical. So we get 6. Next step. Square both sides. Good. And then add 2 to both sides. Y equals 38. That's basically the same problem we just did. But you can kind of see the pace of these and how they should be going. Here, we cannot isolate both sides. Okay? So we just have to go straight to squaring, and we'll have a little bit of work of squaring the right-hand side. So we get x minus 12 on the left, on the right-hand side. 4, 2 times 2. Minus, what do you get in the middle there? So you can get a minus 2x, minus 2 root x, and a minus 2 root x, so it's going to come out to minus 4 root x. And on the back end, you're going to get negative root x times negative root x, which is x. So remember, if you need to, just go ahead off to the side, write it out, okay, and you can prove to yourself. But after doing enough of these, like after tonight's homework, you'll probably be able just to, think of 2 times 2, 2 times negative root x, 2 times negative root x is negative 4 root x, and then negative root x times negative root x is just x. All right, go ahead and isolate the radical. So I'm going to move the x, move 4. That's 0. Negative 16. That's 0. That's 0. Negative 4 root x. Divide both sides by negative 4. We got 4 is equal to root x. And lastly, square both sides. Okay, so that's our potential answer, we'll call it. We don't know for sure until we check it. Go ahead and check it. Is it good or no good? We good this time? So we have 16 minus 12. I want to know, is that equal to 2 minus the root of 16? So here we'll get, no? Square root of 4 is 2. Here we'll get 4 minus, 2 minus 4, that's right. So that equals negative 2, right? No good. No good. No solution. That's it. Yeah, so this will be true or false. If it's false, it's no solution. If it comes out to 2 equals 2, then it is a solution. Sometimes you can get 2 solutions and one of them doesn't work. It is a quadratic. I intentionally gave you a couple of them that are no solutions so you can see what happens. So alternate universe, alternate problem, if it came out to 2 equals 2, then I know 16 is an answer. If it comes out to a true statement, this is an answer. If it comes out to a false statement, the numbers don't match, in other words, then it's no solution. All right. Lastly, here I mentioned before, most of them square root, but some of them are higher powers. Just know when you get here, don't change anything really, except the fact that if it's raised to the 1/3 power, which means it's a cube root, no, that's what that means, is cube root. Instead of squaring both sides, you have to cube both sides. That's the only thing that's different. Everything else is identical. 3n plus 2 equals -1. 3n equals -3. n equals -1. And then do a check to make sure -1 actually works. So you can see the work, the difficulty, and everything is identical. And does it work? I'm going to check it. -1. 3 times -1 is -3. -3 plus 2 is -1. -1, what's the cube root of -1? -1. -1 plus 1 is 0. Yeah, -1's an answer. It's 0 on both sides. So not too bad there. Just Carol out of the way for time being. All right, quick on number 6. What's different about this? It's just an inequality. So instead of getting one answer, we're going to have many answers. We're going to actually have a range of answers. Many different answers. Fractions, decimals, all sorts of fun stuff. Same steps. So first step would be move 2 over, it's not in the radical. So we get 6. Square both sides. Add 4. Divide by 4. Anything, any number less than 10. It works. So if I plug in any number less than 10, it should give me a true answer. So if I plug in 1, does that work? So 4 minus 4 is 0, square root of 0 is 0, -2. Is -2 less than 4? Yes. So if I plug in 0, that should also work, because that's less than 10. Plug in 0, does it work? 4 times 0 is 0. 0 minus 4 is -4. Can you take the square root of -4? No. So we still have a restriction in that if they say, oh yeah, any number less than 10 and it's dealing with a square root, you can't have negatives inside a square root. If this came out to greater than 10, I wouldn't be worried. You can have, big positive numbers, but we cannot have negatives inside a square root. So to counteract that, account for it, we also need to do the domain. If this ever says, yeah, anything less than 10, anything that's negative will work inside a square root, if that ever says that, nah, that's a problem. And that's what this additional step says over here. Always set the radicand greater than or equal to 0. In other words, find the domain. You guys remember this from the beginning of the chapter, that we cannot have this part be negative. It has to be 0 or bigger. So bigger or equal to 0. And then when you solve this, you notice that Yeah, it's in fact, no numbers less than 1 will actually work. So even though this is saying everything less than 10 works, the domain is saying, yeah, everything less than 10, but also it has to be bigger than 1. So in truth, that's everything between 1 and 10. Any numbers between 1 and 10 will actually be solutions. Okay. And you want to write your answer this way in your in-between format. So, how did I know to do this? Because this was pointing towards, this includes negatives. Includes negatives inside a radical. That's how I knew to do that. This is saying, yeah, any numbers less than 10 work inside this radical. When you see a radical, it's like, no, negatives don't work inside a radical. I know that, even though you're saying it does. That's why I need to do this. Is it greater than? No problem. You can be positive all you want. No big deal. All the numbers bigger than 10. No big deal. This is one of those little gotcha things that, I know I've had people finish their test, turn it in, and realize, oh, I forgot to do that one step because you can't have a negative. It's one of those small little things. But if you can remember this little part, right, with the exception of this right here, remembering to do it, pretty overall, really good section for everybody on quizzes and tests. Squaring both sides and solving, not too much, not too many little tiny details like the cube roots and fifth roots and all that other stuff. Okay. Yeah, if this is like square root of x plus, something like this, 5, and the answers came out to, x greater than or equal to 10, that's fine. Because we can put any positive number inside the square root, so we wouldn't have to worry about domain issues. It's just when our answer is kind of contradicting our domain. This is saying everything less than 10 works, and our domain's saying, only everything bigger than 1 works. So the compromise between these two is just, okay, everything between the two numbers is what's going to work. Okay. My guess is this will happen on all the questions, though. I want you to show that you understand this. So just for safe measure, always do the domain, just to make sure, until we have an intuition about it and when to use it and when not to use it. I guess that's it, right? All right. So group quiz tomorrow. Have all your work, including this one, finished. Make sure you go back and complete anything that's not done. You're going to be working on your group quiz. If there's even 1 or 2 questions missing, unfinished on one of those homeworks, you're not getting credit for it. Okay? You got to have everything done.